Day 353 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 94, binary tree and order traversal. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go on and check out that link in the description so you can get you some. Now let's see what the question says. Given the root of a binary tree, return the in-order traversal of its nodes' values. All right, y'all, that sounds simple enough, and I feel like as being the great leak coders that we are, it's important that we understand what an in-order traversal is and how to complete one. So first thing to know about an in-order traversal is we are going to traverse the tree from the left subtree first, then the root, then the right subtree. So let's go ahead and take a look at these examples just to make sure you understand what we are doing, and understand what I mean by that. So in example 1, input root equals the binary tree 1, null, 2, and 3. Output is 1, 3, and 2. It gives us an explanation right here by giving us a picture of the binary tree. So when we look at this binary tree, remember what I said, we're doing the left subtree first, then we're doing the root, then we're doing the right subtree. So we're starting from 1, right? We look to the left, we see there is no left subtree to traverse, so we could just start with 1. Boom, so we put a 1. Then we come down to this 2. When we look at this 2, we still have to do it, repeat the same thing, right? So we start from the left subtree. We do the left subtree first, boom, which is a 3. Then we do the 2, and then we would do the right subtree, but there is no right subtree. So we just do the 3 and the 2, and that's how we get the output 1, 3, 2. Because first we would do the left subtree, no left subtree. So we come here, do the root, which is 1, boom. Then we come here to the 2 and do the same thing, do the left subtree, which would be 3. So that's how it goes, 1, 3. Then we would do the current node or the root, and in this case it would be 2. So then we do the 2, boom. Then there is no right subtree to this 2, so we can stop right there. Now, in case that didn't make sense, let's go ahead and take a look at example 2 where the tree is a little larger, and I hopefully will be able to make it make sense a little bit more. So in example 2, we have the input root equals the binary tree 1, 2, 3, 4, 5, null, 8, null, null, 6, 7, 9. Output is the binary tree 4, 2, 6, 5, 7, 1, 3, 9, 8. So let's go through this with our in-order traversal, looking at the explanation so we can understand how that they got this output. So we're starting at 1 would be the root. We come down to 2. Remember, we're doing the left subtree first, so we come down to 2. Then from 2, we do the left subtree of 2. Left subtree of 2, we get 4. Boom. We look to see there is no there is no left subtree of 4 or right subtree of 4, so we could start with 4. So that's where we put 4 right here. Boom. Then we come to 2. Boom. Add the 2. Boom, then we come and do the right subtree of 2. When we do the right subtree of 2, we see a 5. When we see 5, we see that a 5 has the left subtree. So we come do that left subtree first. So then we do the 6. Boom, we put the 6 right here. After we do the left subtree of the 5, we come up, we do the 5. So we put the 5 right here. Boom, then we come down, do the right subtree of the 5. That's a 7. We put the 7 right here. Now we have covered this entire left subtree of this 1, of the root node 1. We did everything here. So now we could come up and we could append 1. Boom, we put 1 right here. Now it's time to do the right subtree. So we come down to 3. We check the left of 3. There is no left subtree of 3. So we could just come back. Then we put the 3 right here. Boom. Then from the 3, we come down to the 8, but we see there's a left subtree to 8, 9, right? So we come down here, grab the 9, put the 9 in, then we come back and grab the 8 and put the 8 in right there. And this leaves us with our final output of after doing the in-order traversal. So just remember, we do left, then we do the root or the current node, and then we do the right. Boom. So let's go ahead and look at example 3 and example 4. They're pretty simple. Example 3, the root is a blank subtree, so we could just, binary tree. The root is a blank binary tree, so we could just return a blank array for that. And then for example 4, the input root equals a binary tree or an array of just 1. So since it's just 1, there's nothing else to traverse except for 1, so we could just return the 1. Boom. So now I hope that made sense to y'all. Just remember, in order traversal is left subtree, current node or root, right subtree. And if you do it on the well, let's get into the question and I'll show y'all. But now that we understand the examples, let's get into the fun part, the actual solution, y'all. So first thing we are going to do is we're going to declare a variable. We'll call it ands. We'll set that equal to an array of integers, just like that, and put the parentheses. Now, ands is going to store the final in order traversal for us, right? It's going to store, this is where we're going to store the output. Boom. Then we're going to come right here and we're going to create a variable called stack. And we're going to set stack equal to an array of tree nodes. Put the parentheses at the end. Put a question mark after tree node and then put the parentheses at the end. And we'll use this to keep track of the nodes as we go deep into the left subtree. Now we're going to declare another variable called cur. We're going to set that equal to root. And cur is going to be the current node that we're processing, and we're going to start with the root of the tree. Now we need to continue looping as long as there's a current node to process or the stack is not empty, which means there are no nodes to return. So for that, we're going to come right here. We're going to say while cur does not equal nil, vertical line for or. So while cur does not equal nil, or we're going to put exclamation point stack dot is empty. So while cur does not equal nil and stack is not empty, that's what the exclamation point means. We're going to open up the bracket. Now we need to go deep into the left subtree, pushing each node we visit onto the stack. So for that, we're going to say while cur does not equal nil, we're going to open up the brackets. We're going to say stack dot append, open up the parentheses, cur. And that's going to save the current node for later after its left subtree is done. Because remember, when we might come down and see a 2, but we can't, when we start from the root 1, we might check the left subtree, we're going to see a 2, right? But we're going to save this 2 for later because we know 2 has a left subtree, so we can't use 2 right now, or we can't append 2 until after we finish traversing the left subtree, which in this case would be 4. And after we append the 4, then we can append the 2. So we need to save the current node for later after its subtree is done, and that's what this stack.append cur is going to do. Then we need to move to the left child, so we're going to say cur equals cur exclamation point dot left, just like that. Now, after all that, once we hit nil on the far left subtree, now we need to pop the last node from the stack or the most recent unvisited node. So we're going to come right here and we're going to say cur dot stack dot, not dot stack, cur equals stack dot remove last, just like that. Put some parentheses. Now we need to add the value of the current node to the result array, since in order traversal we will visit node after the left subtree. So for that, we are going to say if let val equals cur dot val, cur question mark dot val. We're going to open up the brackets and we're going to say ands dot append, open up the parentheses, dot val. Now we need to move to the right subtree of the current node to continue the traversal. So we're going to say come underneath this, and we're going to say cur equals cur question mark dot right. Boom. Now, when the stack is empty and there's no current node, that means we visited all of the nodes and we can return the final in order traversal result. So for that, we just have to come right here, and all we have to do is say return ands. Just like that, y'all. Now that should be all she wrote for our in order traversal. Let's run it. Make sure it runs properly before we submit it. And it's accepted, y'all. So let's go ahead and submit it. Make sure it stays accepted. Let's see. And it's accepted, y'all. Look at that. 0 milliseconds beats 100% of users with Swift. That's some good stuff right there, y'all. Those are the numbers I like to see. So before we leave, make sure you get one more look at the code. This is the top part. Boom. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.